for application of electrochemical cells. So commercial cell or batteries. Galvanic cells or voltaic cells are used as a source of electrical energy. These cells are commonly called as commercial cells or batteries. Now we are going to write the definition. This is not the definition. Is a group of galvanic cells where chemical energy of spontaneous redox reaction is converted into electrical This is the definition. Now, there are some characteristics it has to satisfy. A, this is important for exam. A useful battery should have the following characteristics. First of all, battery should not be so heavy. Otherwise, you cannot carry it. Suppose your mobile is 200 grams and a battery is 5 kg. Is it possible? it should be live. And back, you have seen no, how your mobile batteries are so slim, so that it can be used as a portable electric generator. Second, its voltage should not vary. Its voltage should not vary appreciably during its use. Third, it should have reasonably long life. Long life. See, we are not using torch for long time, but battery is working. So when is it is in use and what when it is not in use. When it is being used and it is not being. These three are important for your exam. Okay, let me have a glass of water. Finished? Okay. Now we go for its classification. Actually, battery itself is a plural word, but still we say batteries. Primary cells or batteries. And this is secondary cell or batteries. Okay. Now let us try to see primary cell. Primary cell is in one sentence I can say these are use and throw. That is, these batteries cannot be recharged. So now we cannot write it like this. Nah, definition. Many things we say in brief, but this cannot be a scientific definition. This is the one first I told you. The beginning that first they have taken electrochemical cell. I told you that if you send the current in the reverse order, then electrochemical cell behave like an electrolytic cell and reactions are reversed. This is the This is the cell that we use in our torch. These are we using in our watches, calculator, hearing aid, okay, camera. But this camera we are also using rechargeable. Okay.
Yes, sir.
Okay. Now we'll go for secondary cells. In these cells, electron response can be reversed by an external electron energy source. Please remember, passing electric current means it should be DC, direct current, not AC. And use again and again. That is, we can keep it for a long time. Anything which you keep it for a long time, we call storage. Hence, these are also called storage cells. These batteries are also called as storage. Example, what you can write now here. Automobile battery, then mobile. Sorry, I'll tell the exact name. We call it flat storage battery. It is for automobile or inverter. Okay. Nickel cadmium. This is now we are not using it. This is nickel cadmium. What we are using these days? Lithium. We are using now lithium cells. What do you use? Mobile.
Done, sir.
Okay. Now we'll go for examples. For primary cell, then we'll go for secondary cell. How does it work? What is the chemical reaction? But you know that my drawing capacity is very bad. Hmm. So you open the textbook and try to draw this dry cell. All of you are having textbook now.
Yes, sir.
Open and draw dry cell. Okay. So please excuse me for my bad drawing. How? Why did I do like this? Because this you have to view from inside. If you hold better, you can break and see. But don't break the new one, huh? Science students know all this. It's a horrible drawing. So please excuse me. You have better you find something like this now. So this is the positive terminal and this is the negative. You'll find it better is printed also, not here, but on the side. Okay. So this is positive. It is in our time, battery's outer can is made of zinc and it was being covered by paper. This is to make it leak proof. It is again being covered with a steel plate. Okay. So this is the negative. Now you find this is airspace being kept. Okay, this is the airspace. So the some gas is generated. You can show here. I show you where from the gas comes. This is made of asphalt. Asphalt is that one by which we make the black tar. Okay, is being used so that to avoid any leakage from to the upper plate. Asphalt seal. Now here you are having the chemical substances are there. This is the graphite electrode. You'll find if you break it, you'll find a pencil-like thing is there. Okay. Graphite rod is there. It is cathode. Okay. And inside one is made of zinc. Right now here, zinc can, which is a container. What is this? And this is what? A metal jacket made of steel. Okay. So now here it is the paste of manganese dioxide, ammonium chloride, zinc chloride, and carbon powder. Carbon powder is being used to absorb water. Okay, this is the better. Draw. You can draw better from book. Draw it. Description you read from book. I'll write down only the chemical reactions. See, zinc is the anode, and cathode is what? Cathode is graphite. But I told you, in electrochemical cell, when the electron reaches the cathode, cathode do not accept it. They simply hold it and pass it to the ions. So ultimately, you find in the cathode some chemical compound. So I'll write now here reactions at anode. See here, zinc, you know, famous. Zinc 2 plus 2. So this electron now travels because the entire body now conduct electricity. Nah? You don't have to put in electrical wire. Now reactions at cathode. See here. we have taken here ammonium chloride. Ammonium chloride. So here NH4 plus. Okay, NH4 plus. How the NH4 don't write? How the NH4 forms? See here. NH3, because you know nitrogen has a lone pair. This when it accepts, you get what? You get here N, sorry, it forms a coordinate bond. You get now here this. Okay, so let me write it reverse. If I write it like this, NH3 plus H plus. See now this H plus will take free electron. Why should you take when the electron is moving around it? Why should it go and approach the ammonia? So I can write like this. H plus plus electron gives us what? H. All right. So you will not write anything. First try to understand. I'll write it separately for you so that you should remember. How many electrons are there? 2. So I write it now here. 2. So it will give you 2 and 2. 2H plus 2 electron, and it will give you what? 2 hydrogen. All right. So this is the role of ammonium. So what the ammonium chloride does? It carries the electricity. So ammonium chloride is the electrolyte. So electrolyte will carry the electron to whom? The electron should go somewhere, na? See now, electron has been taken by hydrogen. Now, what you have here now? Manganese dioxide. Manganese dioxide. Also, what is the oxidation state of manganese dioxide here? Plus. Manganese dioxide, when it reacts with hydrogen, okay, one hydrogen, what it will happen? It will give you MnOOH. Let us see how does ammonium manganese dioxide looks like. See, manganese dioxide, why is oxidation state is +4? See here, it is having two. It is having manganese oxygen double bond. This is double. All right. When the hydrogen comes, what happens? Hydrogen X. What you will have now here? It will be this, because valence of oxygen cannot be more than 2. What happens now here? It becomes this. See, this is +4 and this is plus. +4 become plus. So here manganese dioxide is acting as a cathode. That can be asked sometime in your entrance exam. So in a dry cell, which is actually the cathode? Manganese dioxide. Which is the electrolyte? Ammonium chloride. All right. Now you may feel where from sir has got +4 and +3. See, you know it how to find oxidation state. MnO2. So I write here, this is A and this is A. So A plus, how many oxygen? 2. 2B is equal to 0. We know oxidation state of oxygen is always -2. So A plus 2 into -2 is equal to 0. Therefore, A is equal to +4. Done. For this one, I'll do for this one. For this. So here it is MnOOH. See, how many elements are there? Manganese is 1, oxygen is another, and third one is hydrogen. So I'll write like this. How many oxygens are there? 2. So I'll write now here A plus 2B plus C is equal to 0. So I want to find what manganese. This is manganese. So oxygen is -2. Hydrogen is +1. So it is what? A minus 4 plus 1 is equal to 0. So A is equal to plus. That is manganese dioxide takes the oxygen. Okay, so now you want to write, huh? So don't write it here. You write in the left hand side of your copy. because I'll write the final equation and I'll add it. Just I have shown. So you write it somewhere like this, okay, box, and write this equation, and you can show also the oxidation step so that you should not forget. It's not a magic. After that, I'll rub it and write the equation, and I'll complete the equation here. Please. Put it in here so that I can do some addition. Okay. So I'll write it now here. 2NH4 plus MnO2 plus 2 electron gives us manganese hydroxyoxide. This is called manganese hydroxyoxide plus 2 ammonia. See, this is the ammonia which goes in this case. Don't worry, this ammonia we have added a substance which will going to absorb them. So now I'll add it. You always write reaction and not followed by reaction rate. But then after that, when you make the total, you write here overall. What is the overall reaction? This and this will get cancelled. This is the electron which gives us electricity. Well, right now here, zinc yes, NH4, 2NH4 I'll write here aqueous because it's a paste. 2 MnO2 is also solid. So it will give you Zn2 plus aqueous because it is iron plus 2NH 2Mn O hydroxymanganese oxide and 2NH3 which comes out with more gas. So this is the reaction which takes place in your tiny small battery which you are using it. Okay. Now, if I finish right, then I have to tell you.
Done, sir.
Okay. Now, see, the cell which you are using in your wall clock or in your torch or in any other places, does it smell of ammonia? It never smell of ammonia, but ammonia is generated. Now, then what happens to the ammonia? So what we write now? The ammonia liberated at cathode immediately combines with zinc chloride. See, this is zinc chloride to form a complex. See, this is the beauty of chemistry. Okay. What happens now? In your book, they have mentioned it, but they have given a half equation. I write the full equation. So, okay, I'll write like this. Because zinc chloride ionizes zinc. So, 4 NH3 will give you Zn NH3 4. So, you get a complex. So, in that case, ammonia is being trapped. Otherwise, if the zinc does not react, so much of ammonia will be stored inside the cell, it will lead to explosion. Okay, so this is called tetra C double M, tetraamine zinc 2. It forms a tetraamine zinc complex. Okay, let's rub this one. It gives a voltage approximately 1.2 volt to 1. These days, of course, you also have this rechargeable dry cells. Rechargeable dry cells are there. In rechargeable dry cells, we are using sodium hydroxide. That is something a different story. Okay, 1.2 volt to 1.5 volt. Now the question may come: why dry cell cannot be recharged? See, dry cell cannot be recharged because gradually the concentration, if the when this ammonia is being decomposed, ammonium chloride is being decomposed. So as the concentration of the electrolyte decreases, this is irreversible. This reaction cannot be reversed. So because of that, you find the dry cell cannot be recharged. We cannot recharge this typical dry cell. Okay. Now another question is there. I think you might have seen also that dry cell, if you keep it for a long time, the battery become very soft, and sometimes it leaks also. Now, why does it happen? See, it happens because ammonium chloride is acidic, so it corrodes the. See, is it not a zinc ion? When zinc metal is being converted to zinc ion, so the corrosion of the outer can takes place because outer can is made up of zinc only. So due to corrosion, then it develops hole. First of all, due to corrosion, the thickness of the zinc can decreases, so it becomes soft. And if the corrosion is more, it generates hole. Because of that, leakage takes place. So you need not be so scared. So what you find when you are using this dry cell, gradually you find that your brightness of your light is decreasing. And time comes when you find only one LED filament you can see. Why does it happen? Why the voltage decreases? I told you, voltage decreases because the concentration of the electrolyte ammonium chloride decreases. Because of that, generation of electricity also decreases. So voltage decreases. So, but you want, you have seen in your house, you are using this type of dry cells in your wall clock. So wall clock will work very fine for a few months. Then gradually you'll find either it is running slow or you're going fast. Why? Because this voltage is changing, and you know a time may come, it may stop. But same thing you do not find in your wristwatch. In wristwatches, it gets perfected, but suddenly you find the wristwatch stops. That is, the cell stops functioning. So the cell which is being used in a wristwatch, these are called constant voltage primary cells. Okay, constant voltage primary cells. So I'll tell you the secret behind this. Okay, constant voltage primary, because dry cell does not give us constant voltage. All right. Example is what? Mercury cells, or also known as button cells. All of you have seen these cells which is being used in your wristwatch. They look like a button only. Because of that, we call them is buttons. Okay. So it will look like this. Again, I'm telling you, please excuse me. What is it doing? Okay. Here also you'll find inside one is zinc and outside is a metal plate, metal cover. All right. See. So here you'll find, here it is zinc. Here also we'll write here zinc and what is this? What is this? Metal cover. Okay. So what is the anode here? So cathode here. Here cathode is here cathode is mercury oxide. Okay, plus it contains zinc oxide. And here potassium hydroxide no. Potassium hydroxide and zinc oxide is being taken as a electrolyte, and zinc oxide as electrolyte. Draw. Better you draw from the book. Book is written very nicely. Don't draw from my drawing. reaction at anode. I'll write the rough, then you will write. So yes, reaction at, okay. So first is zinc S. So zinc, you know, it will give you zinc 2 plus aqueous plus C. What is the electrolyte here? Electrolyte is potassium hydroxide. So potassium hydroxide dissociates to give you potassium ion and hydroxide. Zinc ion reacts with the hydroxide. So it forms zinc hydroxide. But zinc hydroxide, all metal hydroxides are not stable. Like aluminum hydroxide is not stable, ferric hydroxide is not stable, ferrous hydroxide is not stable, zinc hydroxide is not stable. They lose molecule of water and becomes oxide. So zinc hydroxide will give you ZnO plus H2. I'll write that it. See this and this cancels. Then this and this cancels. What you get here now? ZnS plus 2OH aqueous will give you ZnOS plus H2O plus. So here I'm going to write ZnS plus OH 2OH minus, it will give you zinc oxide, because in your book they have not mentioned anything. Because no, they know the students are very intelligent and clever. They know everything. Okay, now what is going to happen? This electron will go to the cathode. What is the cathode here? Here cathode is mercury oxide. Okay, now see here. I'll write reaction at cathode. How does it see? Okay, see here. AgO metal oxides break down to give you Ag2 plus and O2 minus. Now this Ag2 plus will take 2 electron, and you know mercury is liquid of this. Then O2 minus aqueous will react with water to give you 2OH minus aqueous. Let me add. Okay, so this is this. So I'll write now here AgO. Okay, then H2O, 2 electron is mercury L plus 2OH minus. You will not write. See, so shortcut they have written in the book. It is a criminal offense. Student of your age should be explained. It is KGL plus 2OH minus. Overall See this can cancel. This and this get cancelled. This and this get cancelled. So what you get now here? Z and S plus AGOS give you AGOL plus zinc oxide. Okay, so now you'll write this one, and this one will put in a box and you write it. So, all right, done.
Yes, sir.
See, let me rub this portion and write something here. This cell produces a constant voltage of 1.35 volt. Now, why it is constant? It's a very interesting thing. In dry cell, you have found in the main equation the electrolyte was gradually depleting, just decreasing. Here in the main equation, do you find anywhere electrolyte is there? So the concentration of the electrons has been constant. So see here, let me tell you one thing. This is not being explained to you. I'll first explain, then I'll write down, then this equation I'll remove, and I'll give you the sentence which you are supposed to write, and in exam you'll write. See. Remember, E cell is equal to E0 cell minus 0.059 n. You know n is equal to 2 here. Log, what do you find here? This is the, I'll write here, electrolyte at anode, anodic cell. And this is electrolyte at cathodic. See here, here electrolyte is same, and their concentration is constant. When the concentration is constant, so what I'll write now here? Concentration of electrolyte is constant. That is equal to what? 1. So I'll write now here, E cell is equal to E0 cell 0.059 by 2, n is equal to 2 log 1. Log 1 is 0. Then whole portion becomes what? 0. So here, what do you find? Therefore, E cell is equal to E0 cell. Means what? E0 cell means standard reduction potential. Standard reduction potential of a metal is always constant. So difference between them is also constant. So it gives you a constant voltage. All right, such beautiful the cell is being made. See, this is called the application of theory. So do you want to write this one? Huh? Or forget? What you want to do? If you write, then you have to be inside a bracket because this is only for your understanding. Or I should remove. Should I remove?
No, sir.
Then I'll write the actual answer. তোর নাম করা কোম্পানি এরকম থাকতে হবে তারপর একটা ক্রেডিট ওই খুলে যে হাজার প্রিন্টে যখন আসিল আমি দুটা ধাক্কাই পাঠাইতাম secondary sales I'll do it on Thursday. Okay, then bye for today.
Thank you, sir.
Thank you, sir.
Welcome.